Okay, fine. So so far আমরা বলছি যে structures এখন যারা জয়েন করলাম আমরা মাত্রই স্টার্ট করছি তোমাদের জন্য ওয়েট করতেছিলাম structures can be of 4 types. Number 1 আমরা ফার্স্টে দেখছি হচ্ছে giant covalents, then number 2 simple covalents or simple molecular, you can say simple covalents, then number 3 এই দুইটা we have done. ঠিক আছে, নাম্বার 3 আজকে আমরা এটা স্টার্ট করব, দুইটাই শেষ করার চেষ্টা করব, giant ionic if time permits, and number 4 we have giant metallic, right? So giant ionic থেকে আমরা স্টার্ট করতেছি আজকে। Giant ionic structure, we have said earlier how ionic compounds will be formed. Ionic compounds will be formed from metal and non-metal. Can you recall? Metal and non-metal will join together to form an ionic compound. Can you recall? Response? Hello?
I got the point.
Yes, sir.
Okay, fine. So say for example, one metal, calcium, and a non-metal, oxygen, they will form ionic bond. So calcium is in group 2, so it is 2+, and oxygen is in group 2, group 6. So from the right, if we count, group 0 is 0, group 7 is -1, group 6 is -2. So see, +2 and -2 will cancel out. So calcium oxide will be calcium oxide, CaO. That is the formula. So these things we have discussed earlier. Jara eta ekhono jader problem ache, please go back to our class lectures in YouTube and solve your problems. Giant ionic structure, ekhane amra jeta discuss kortechi, all ionic compounds form crystals that consist of lattice like structure. Lattice mane ki? What is lattice? Lattice is a regular array of particles. Say graphite is a lattice structure, diamond is a lattice structure. Repetition of the same thing, repetition of the same thing, same pattern যদি repeat করে এটাকে, say for example এটা দেখো, repetition of the same pattern, so এটাকে আমরা একটা ল্যাটিস বলতে পারি। So a lattice fence, lattice is a regular repeating structure, so that is what we need to understand. So all ionic compounds, they are crystals and they form lattice with positive and negative charge, they alternate together. So it's a regular array of particles. The lattice is held together by strong electrostatic attraction between the positively and negatively charged ions. You can say cations and anions as well. So we will show you by diagram. So see, this one is sodium chloride. How a lattice of sodium chloride is formed is given here. See, ash color balls, these are sodium ion, and chloride is larger. So that's why we have given a larger green color ball. So if you put them one after another, then it will be like this. And so this is a, you can say millions or billions of sodium ion and chloride ion joined together to form a very small lattice. Say for example, এখানে তোমার এই যে টেবল সল্ট যেটা আমরা যেটা খাই আর কি, টেবল সল্ট এটা আছে, এটার জাস্ট ওই যে একটা স্মল যে ভেরি স্মল একটা দেখো না পিস, ওই পিসটা হচ্ছে এরকম এটা, আর এখানে কয়টা বল আছে, millions and trillions of sodium and chloride ions are there inside a small lattice. That's why it is not giant by its size, rather it is giant by its number of particles present or number of ions present inside a lattice. Do you understand?
Sir.
Yes, sir. Yes, sir.
Okay, so আমরা যদি এইটুকু জায়গা এক্সপ্যান্ড করে তোমাদেরকে দেখাই, এটা এরকম দেখো, এটা একটা তোমার কিউব আছে এখানে। সো এই কিউবে যদি আমরা একটা ক্লোরাইড, একটা সোডিয়াম, একটা ক্লোরাইড, এভাবে আয়নগুলো যদি আমরা এভাবে বসাইতে থাকি, alternate positive and negative charge, then it will occur like this. So what we can do in the exam hall, we can give this picture and we will give some balls missing, and you need to put those balls in the proper places. See, two sodium ion or two chloride ion will never be in the same never be together. See, chloride, sodium ion, chloride. So that's how it goes. Please look at the
Sir,
diagram.
how are we supposed to memorize the shell setting of this?
Which one? Memorize.
The cell, what can I say? The shell arrangement of this.
Shell arrangement of this. You want to memorize.
Why would, because if everything has the different parts, it would be a bit difficult.
Everything is
If every type of, what can I say, ions or has a different type of cell, cell arrangement, it will be a bit difficult to understand, right?
কই এটাতে সেম তো সবগুলাই সে ম্যাগনেসিয়াম অক্সাইড এখানে জাস্ট একটা ম্যাগনেসিয়াম একটা অক্সিজেন একটা ম্যাগনেসিয়াম একটা অক্সিজেন একটা ম্যাগনেসিয়াম একটা অক্সিজেন সেমই তো হবে সবগুলাতে কেন ডিফারেন্ট হবে ইফতেখার
That's why you said that we need to place it like that, then two of them won't be in the same structure and stuff.
Okay, fine. But yes, all the ionic lattice they don't have this same shape. But the shapes which are complicated, these are not part of your O-level exam. You will be just given with this simple one cation, one anion, one cation, one anion. There are other types of shape as well, but this we'll discuss in A levels, not now. Even not in A levels, we'll discuss. It's if you study chemistry in further in university level, then you will get. But for the time being, you will get this simple: one magnesium, one oxygen, one sodium, one chloride. That's how it goes. So that is it. Number 1 point. Number 2, if you look at one central sodium ion, see how many chloride ions are present around this central sodium ion? Can you tell me?
2.
Huh? What? 2. It's a 3D structure. You need to understand. It's a 3D diagram. So with this central
3.
sodium ion, red, say red, 3, no, 5. You see, with this sodium ion, we have one chloride at the top, another chloride at the bottom, one chloride at the front, another chloride in rear side. We say this is frontal and dorsal. You see? You see? You understand? See this
Yes,
one.
sir.
If you look at this one is one sodium, right? One sodium, red marked. So you see right, left, up, down, one at the back, and if we continue, one will be at the front. Do you understand? 6 chloride ions around the sodium ion, and around the chloride ion, you will get 6 sodium ions as well. You see? If you look, if you take any chloride ion, say this one is a chloride ion, right? So around this, see 1, 2, 3, 4 back, যেটা তুমি দেখতেছো না, রেয়ার পার্টে একটা আছে আর ফ্রন্টাল, আমরা ফ্রন্টাল বলি। এটা যদি আমরা কন্টিনিউ করতাম তাহলে ফ্রন্টে একটা থাকবে। Each sodium ion will be joined with 6 other chloride ions, and each chloride ion will be joined with 6 other sodium ions to form a big lattice. So that's how it goes. And this is a lattice structure, means this is the pattern will be continued. ঠিক আছে, বোঝা যায়?
Yes.
Yes, sir.
Okay, very good job. So if we read from here, it's like see this I said already. The structure of sodium chloride is described as giant ionic lattice. We are using the word giant here, not in the sense that I'm already. All the sodium ions in the structure attract the chloride ions. We cannot pick out sodium chloride molecule. Sodium chloride, we cannot say sodium chloride is a molecule. Why? Because sodium chloride is not a molecule, as it is a structure, big lattice structure. So we cannot pick only one sodium ion and one chloride ion. But why the formula is sodium chloride then? Because you have same ratio of sodium and chloride ion always. If you have 1 million sodium ion in a lattice, you will have 1 million chloride ion in that lattice. So that since the ratio is 1,
Yes, sir.
that's why the formula is NaCl. Since the ratio is 1:1, that is why the formula is NaCl. So these are no individual molecules, so they are not individual NaCl, one sodium atom and one chlorine atom joining together to form sodium chloride. No, it's not like that. Rather, many sodium, trillions of sodium and trillions of chloride will join together, but the number will be 1:1 ratio. That's why the formula is NaCl. The bonding in a giant ionic lattice extends toward the structure in all directions. There is no limit to the number of particles present. All we know is that there must be the same number of sodium and chloride ions. So the ratio is 1:1. So that is it. Now, the structure of magnesium oxide, if you see, magnesium oxide similar structure, but in this case, magnesium is 2+ charged and oxide is 2- charged. So this is because the only difference is that magnesium oxide lattice is held together by stronger forces of attraction. Why stronger? Because 1+ charge and 1- charge, the attraction between 1+ and 1- charge will be less than 2+ and 2- charge. Do you understand? That's why the bonding between magnesium oxide lattice, the melting or boiling point of magnesium oxide lattice is much larger than sodium chloride.
Got it, sir.
So that's how it goes. It's easy to understand, just you need to keep in mind. The physical properties again, just like carbon, diamond and graphite and simple molecular, we'll discuss the physical properties of different ionic substances. Number 1, ionic compounds have high melting and boiling point because of the strong electrostatic force of attraction, which will hold the lattice together. So we need to supply a lot of energy, need to be supplied in order to break all these strong electrostatic force of attraction. Thereby, ionic compounds tend to have very high melting and boiling point. Say sodium chloride, the melting point is 801 degrees centigrade. তার মানে কি, তুমি যদি একটা স্মল সোডিয়াম ক্লোরাইড, ওই যে টেবিল সল্ট যেটা, এটা যদি নিয়ে তোমার বাসায় যে কিচেন আছে, কিচেনের ওই বার্নারের মধ্যে যদি ফালায় রাখো, 1 বছর 2 বছর পরেও দেখবে এটা ওইভাবেই রয়ে গেছে। It will never melt. কারণ তোমার ওই স্টোভ এত টেম্পারেচার জেনারেট করতে পারে না। বুঝছো?
Yes, sir.
Yes, sir.
They are so, the electrostatic force of attraction is so strong. 801 ডিগ্রি জেনারেট করতে তোমার একটা ওই ব্রিক ফিল্ডে যাওয়া লাগবে। ব্রিক ফিল্ডে গিয়ে ওইখানে গিয়ে সোডিয়াম ক্লোরাইড যদি ফেলে রাখো, তাহলে that can generate 801 degree. So it's a huge temperature. আচ্ছা, number 1 point. Number 2, ionic compounds tend to be crystalline. এটার কোনো রিজন দরকার নাই, it is an information only. এই ডেসক্রিপশন গুলা is not required. So tend to be crystalline মানে হচ্ছে they tend to form crystals. এই যে এরকম ক্রিস্টাল ফর্ম করতে চায়। হ্যাঁ, কিছু আছে, কিছু আয়নিক কম্পাউন্ড আছে যেগুলো পাউডার ফর্মে থাকে, পাউডার ফর্ম, এরকম পাউডার্ড হয়ে থাকে। বাট মোস্ট অফ দ্য আয়নিক কম্পাউন্ডস ইউ ফাইন্ড, দেখো কথাটা আমরা লিখি নাই যে আয়নিক কম্পাউন্ডস আর ক্রিস্টালাইন। We wrote ionic compounds, they tend to be crystalline. They want to be crystalline. Means most of them are crystalline, some of them are not crystals. They are rather powder. So powdered form. Right. So this is number 2, no reason required. But if they ask why ionic compounds have high melting and boiling point, you need to say they have strong electrostatic force of attraction which held the lattice together. To form a big lattice, you need very high energy to overcome all these force of attraction. So 2 marks they will give. And you will find this question in many past question papers. Next point, number 3, ionic crystals, they tend to be brittle. Brittle মানে তুমি যদি সোডিয়াম ক্লোরাইড যে সল্টটা আছে, এটা যদি, even though you need very high melting and boiling point in order to separate them, but if you just take sodium chloride crystal on your fingertip and just এই যে স্ম্যাশ করো, দেখো ওটা ভেঙে গেছে, তাই না?
স্যার এত হাই সেলসিয়াস কিছু করতে পারে না, হাত দিয়ে কেমনে ভেঙে যায়?
রাইট, কেন ভাঙে এটাই এখানে এক্সপ্লেইন করতে। এটা তোমাকে জিজ্ঞেস করবে যে why ionic crystals, they even though they have very high melting and boiling point, why they tend to be brittle. এটাই তোমাকে জিজ্ঞেস করবে ওরা for 2 marks or 3 marks in the question paper. So দেখো এটা হচ্ছে আমাদের একটা ল্যাটিস, পজিটিভ নেগেটিভ পজিটিভ নেগেটিভ নেগেটিভ পজিটিভ নেগেটিভ পজিটিভ, দেখো এরকম আছে লেয়ার, ওরা লেয়ারে আছে এরকম। এখন if you apply large force in any of this layer on any of this layer, দেখো যখন তুমি ফোর্স অ্যাপ্লাই করতেছো যেটা হবে এই নেগেটিভ চার্জটা এখানে চলে আসবে, পজিটিভটা এখানে চলে আসবে, একটু লেয়ারটা স্লাইড ওভার ইচ আদার করে করলেই যেটা হইতেছে দেখো দেখো নেগেটিভ নেগেটিভ পজিটিভ পজিটিভ নেগেটিভ নেগেটিভ পজিটিভ পজিটিভ, মানে লাইক চার্জেস উইল কাম ইন দ্য সেম প্লেস। এই দেখো নেগেটিভ নেগেটিভ পজিটিভ পজিটিভ নেগেটিভ নেগেটিভ পজিটিভ পজিটিভ, বোঝা যায়?
Yes, sir.
And we know like charges repel. Like charges repel. So like charges repel. So ওরা যদি repel করে, then they will be split from each other, and you will see it is smashed and it is being broken. It is brittle. That's why it is brittle. Fine. Number 3.
Yes, sir.
So এটা কিন্তু ভুলো না, এটা আসে কিন্তু এক্সামে খুব বেশি আসে, very important point এটা, স্টার মার্ক। Number 4, ionic compounds, they tend to be soluble in water. We are not going to discuss the reason here. Number 5, ionic compounds tend to be insoluble in organic solvent. Means organic solvent means oils, alcohols, these are organic solvents, and we are not giving the reason behind, so they will not ask you. এটা আমরা দেখবো, এটা আরো অনেক পরে দেখবো। এই যে আয়নিক সাবস্টেন্সেস দে টেন্ড টু বি সলিউবল, কেন তারা সলিউবল হয়, মানে তুমি 801 ডিগ্রি সেন্টিগ্রেড টেম্পারেচার লাগতেছে ওদেরকে সেপারেট করতে, বাট ওয়াটারের মধ্যে দিছো 25 ডিগ্রি সেন্টিগ্রেড টেম্পারেচারে ও ডিসলভ হয়ে গেছে, হাউ ইট ইজ পসিবল? সো এটা আমরা দেখবো, মানে দে উইল বি স্প্লিটেড ইন ওয়াটার, সোডিয়াম আয়ন এন্ড ক্লোরাইড আয়ন, দে আর সেপারেটেড, হাউ ইট ইজ পসিবল, দ্যাটস উইল শো লেটার অন। It extension work, it is just you can read, but it's not you can read this, but we will go further detail later on. Why ionic substances they tend to be soluble in water. That is it. The electrical conductivity on ionic compounds, it should be the number 6 point, basically should be number 6 point. Ionic compounds they will be, ভালো করে খেয়াল করো, এটা আমাদের ইলেকট্রোলাইসিস চ্যাপ্টারের জন্য এই পয়েন্টটা ইজ ভেরি ইম্পর্টেন্ট। আয়নিক কম্পাউন্ডস soluble when, sorry, soluble not conductor. Ionic compounds they conduct when, number 1, if they are molten. If you can melt ionic compound, they will conduct electricity. If you melt ionic compound, only if you melt ionic compound it will conduct, or if you dissolve, that is if you make solution by ionic compound, they will conduct electricity. In solid form, in solid state, they will not conduct. বোঝা যায় এটা?
Yes, sir.
Reason বলতেছি, just take the information. Ionic compounds will never conduct electricity in solid form. They will only conduct electricity when they are in molten form or in dissolved form. ঠিক আছে? So the state symbol is the most important thing when you will see when you will answer whether your ionic compounds will conduct electricity or not. So in the electrolysis chapter which will come forward, it is the most important part. You should not forget these two things. Ionic compounds do not conduct electricity in solid form. They only do conduct electricity when they are in molten or in solution form. Afrin, what's that? Afrin?
Yes.
Ryan?
Sir.
Yes, sir.
Okay, good job. আচ্ছা, আরেকটা ইয়ে হচ্ছে তোমাদের জন্য নোটিস, আমি আগেও দিছি, সবার জন্য বলে দেই। If you want to take time from me, you can take from 4:15 to 4:45, half an hour from Saturday to Thursday with prior appointments. আগে থেকে আমাকে হোয়াটসঅ্যাপে নক দিতে হবে, বলে দিতে হবে যে স্যার I want to book the slot for say Thursday 4:15. So I will give you one-to-one time for half an hour for any of your problem regarding any life planning, মানে তোমার career planning or chemistry problem or any problem in any other subject, your homework, school homework. So for these things I'll give you time, but you need to book the slot before, because অন্যরাও হচ্ছে এই স্লট গুলা কাজে লাগায়। A levels Cambridge, Edexcel Cambridge, মানে AS Cambridge, A2 Cambridge, AS Edexcel, A2 Edexcel. So there are many people to book that slot. So if the slot is free, you will get the slot. Otherwise I will give you যে এইটা ফ্রি আছে, so তুমি এটা নিতে পারো। So এইভাবে আমি দিব, so you can take the opportunity. Okay, so that is basically the end of the story. So molten and solution form ionic compounds, they will conduct electricity, number 1 point. Number 2, why? Number 2 and the last point is why, because আমরা বলছিলাম যে if something is a conductor, it needs to have either free electrons or free ions. আমি একটা white page নেই, whiteboard এখানে লিখি, আবার বলি যে to conduct anything conductor, যদি if it wants to be a conductor, number 1, it need to have free electrons. Free electrons মানে simple, a charged particle. Number 2, it need to have we should say or either or. It need to have free electrons or it need to have free moving ions. ঠিক আছে? So for ionic compounds, what is happening? Say sodium chloride in solid state, if you give water in it, AQ means water, it will form sodium ion in aqua state, means your sodium ion is moving throughout the beaker now, and your chloride ion, it is also in aqua state, means it is dissolved. So chloride ion is also moving inside the beaker now. So see, the ions are free to move, right? So this is number 1. Or number 2, sodium chloride in solid state, if you melt, sodium ion will be in liquid state and chloride ion will be in liquid state. So see, in the liquid state, sodium ion and chloride ion, they can move. So ions are moving inside the apparatus or inside the jar you have taken. So for graphite, we say, since graphite has free electrons, they conduct electricity. But for ionic compounds, why they conduct electricity? You cannot say they have free electrons, because they do not have free electrons basically. Only what they have is they have in the molten or in aqua state, in the molten state or in aqua state, they have free ions, or ions are free to move. And since ions are free to move, they will conduct electricity in aqua state and in solid state. Please note it down, very important concept. So this one is for solution, and this one is for molten. So solution state and molten state. Any questions? Any question?
No, sir.
Sir. Ifat, Sadika,
Sir. Hello.
so please take a snapshot or
আছেন
yes.
এই যে স্যার মোল্টেনের এখানে NaCl means solid, right? So when we melt it, so এটা তো Na plus এরপরে সেটা within bracket কি লিখেছেন?
Chloride in liquid state. L,
আচ্ছা।
small l, liquid. State
Okay.
symbol I have given. Okay, right. So next point, let us proceed. আচ্ছা, এখানে কিছু questions আছে regarding, আমরা এখানে অনেকগুলো solve করেছি already. Say number 3 we have solved. State the formula of the ion. When we have studied formula of ionic compounds, we wrote the formula of the cations. Then number 4, work out the formula of the compounds. So formula of ionic compounds we have done. And these questions they can ask. All of these questions will carry 2 to 3 marks. Explain why sodium chloride has a high melting point. I have explained why they do not conduct electricity when solid. Why? Can anyone tell why they do not conduct electricity when solid? I just said.
They don't have any free electrons to move.
Again, free electrons will not go with ionic compounds, I say. Ionic compounds does not have any free electrons, whether in solid state or molten state or in aqueous state. They do not have free electrons. Anyone? Why they do not conduct electricity when solid?
Because there is no free ions to move.
No free ions to move. Exactly, no free ions to move. That you need to say for 2 marks. In solid state, ionic compounds they do not have any free ions which can move throughout the structure. So or throughout, which can move throughout. When they conduct electricity when molten. Why? Because if we melt them, the ions will be free to move, and thereby they will conduct electricity. So that's what you need to write for 2 marks. So this is question number 5, and it's explained. Can anyone tell this one? Number 6. Give reasons whether you would expect potassium chloride to have lower melting point than calcium oxide. Potassium chloride and calcium oxide. Anyone? For you, I'm writing the formula. Potassium chloride and calcium oxide is CaO. This one is potassium is
Except that it would have a higher point than the calcium oxide because potassium is a metal, highly reactive metal.
no. It's not based on reactivity. I say in order to compare between potassium chloride and calcium oxide, you need to know the charges of cation and anion. Look at this. Potassium is 1 plus and chloride is 1 minus, as potassium is in group 1 and chloride is in group 7. Calcium, it is in group 2, so the charge will be 2 plus. And oxide is in group 6, so it is 2 minus. If you can remember. সবাই কি এটা খেয়াল আছে? এটা যে আমি বলছিলাম। If we sketch a periodic table, if you look at the periodic table, for Ryan, I am asking, do you know the charges of all group 1 is +1, all group 2 is +2. These are all transition metals from group 2 and group 3. Ryan, please respond.
No, I didn't know this. I didn't know this.
So just for a quick revision, all group 1 will have +1 charge, and all group 2 will have +2 charge, and all group 3 will have +3 charge. And group 4 normally they form covalent bond. That's why we write they share 4 electrons. And all group 0 or group 8, they are 0 because they will not form any bond, either ionic or covalent. Group 7, from there, if we say 0, -1, -2, and -3. It's very easy to remember. +1, +2, +3, and 4. 0, -1, -2, -3. Ryan, can you remember this?
pretty much recall. I can pretty much recall.
Okay, please go back to the YouTube videos. Did I give you the YouTube channel link?
Yeah, I have, sir.
Just skip some part which are repetitive, but we didn't do any addition in the video. So just যেগুলা হচ্ছে তোমার if you need to skip, just skip them, but you look at what is being discussed earlier, right? So it will definitely help you. So these things all we have discussed in our class lectures, previous class lectures. So go back and see. Okay, so here potassium is group 1, so +1. Chloride is in group 7, so -1. Calcium is group 2, so +2, and oxygen is in group 6, so it's 2-. So you see the lattice which is formed by potassium ion and chloride ion, it is 1+ and 1-. 1+ and 1-. So if you multiply, it's 1, and if you multiply, this one is 4. So calcium oxide, the electrostatic force of attraction between cations and anions present in calcium oxide lattice will be much more, many times higher than potassium chloride. Do you understand?
Yes.
Yes.
Okay, so in this way you need to answer. Huh? So whenever we'll say to ask you to compare between the melting and boiling point of these two ionic compounds, then you need to look at whether they have what are the charges on cation and anion. That you need to find. So that is it. That is it. So it's done. Please, everyone, come back. We will start metallic compound. We'll come back within 2 minutes. We'll start giant metallic, the last one. Giant metallic will start.